Every moment you watch this video, the Earth's population grows. Every moment, more food is needed to feed that growing number of people. But the way that food is created is what scientists say is partially responsible for climate change, a sort of scorched earth method of farming worldwide.
And as long as you have an annual agriculture, where you have to sort of kill off everything that's growing in a field so that you can plant the crop that you want, you are opening yourself up to soil erosion, which limits the number of years that field is available.
How can we possibly keep everyone on our planet fed? Maybe we get to the root of the problem by listening to this agricultural maverick.
We're losing about 30 million acres a year due to land degradation, according to the United Nations. And soil is more important than oil, and soil is as much of a non-renewable resource as oil.
In other words, once the soil for crops is overused, it's useless for our food needs. Ecologist Tim Cruz.
What's the biggest problem we have in agriculture today?
Well, the biggest problem is that how we farm is not particularly resilient or sustainable. We disturb the soil to such an extent that it leaks nutrients, it leaks carbon, it leaks water.
So it can't be sustained in the way it's done.
We simply do not have the resources available on the planet to feed the human population with an inefficient cropping system.
Crops are abundant, but that is almost entirely due to unsustainable and artificial farming methods. So scientists say our long-held way of farming will not be able to last forever on our current trajectory. That's why the Land Institute in Salina, Kansas, and its leader, Dr. Wes Jackson, say a worldwide change is critical. Jackson and his team are not just talking about choosing a few different crops, but something much more profound. Changing the way the world grows its food, to still grow crops without depleting or destroying our resources the way we are now. Jackson says humans actually got off track about 10,000 years ago when hunters and gatherers became planters and harvesters and started farming practices we still use today. One farming practice started then, the planting of rows of annual grains, is still in use today, but that has done about 10,000 years of damage to the soil.
To grow crops the current way, you've got to have seeds, you've got to have labor in the form of fuel, you've got to have fertilizer, and you've got to have chemicals just to get started. All of those, they use a lot of dense carbon, which harms the climate. Even beyond harming the climate, it's really racing toward a future where our resources are even more constrained. Because of an annual cropping system, where we open those soils up, anytime you open soils, it's an invitation to weeds and an invitation to pests. And so chemicals then are typically used to manage those systems. And those chemicals both deplete the soil on their own and harm waters that are nearby.
The carbon that was long sequestered in the land has been disturbed and released, and now much of that farmland is just plain worn out.
The landscape that is plowed, it's like a landslide happening on an annual basis. For millennia, we could remove land from production and fallow it, just leave it be and let it regain fertility. But with 7 billion people on the planet, pushing 9, maybe pushing 11, almost no cropland is going to be fallowed or rested. It's all in intensive production.
According to the University of Minnesota's Institute on Environment, roughly a third of greenhouse gases comes from agriculture-related sources, from deforestation to methane from cattle to the nitrous oxides produced from using too much fertilizer. So over at the Land Institute, it's not your ordinary think tank, no supercomputers or stuffy boardrooms, just experts from all over the world, usually in jeans and work boots in the field, relying on one all-knowing consultant: Mother Nature. For the past 200 years or so, humans have used too much water, too much fertilizer, too many pesticides, and too much fossil fuel, all to try and coax more wheat, more rice, more corn, and more crops out of the earth. Professional plant breeders force the land to produce more and more. The result? In many places, nutrients have been depleted, and yields for crops have gone down. The Land Institute team has demonstrated its brand of perennialism can work, and it's introducing crops for testing around the world, from sub-Saharan Africa to Sweden to Yunnan province in China, where perennial rice is being grown, something that will grow all year round without having to be replanted.
All of nature's ecosystems worldwide feature perennials in mixtures, whether we're talking about a rainforest or an alpine meadow or a prairie. We're featuring the perennial and species diversity, a diversity of them. And then we have the opportunity to take advantage of the efficiencies that we see within the natural integrities, or the integrities of a natural ecosystem. So that's what we want to do, is to mimic the structure in order to be granted the function.
A field with only one type of crop is called a monoculture. Without diversity, a whole crop can be wiped out by a single pest or disease. On the other hand, diversified farmland has its own built-in cavalry. That's called a polyculture, multiple crops. So pests and diseases can't do nearly as much damage. A varied natural ecosystem helps put on the brakes. And there's no scorched earth after a harvest of a polyculture. Instead, perennials provide a lush, living plant cover year-round, just like the native prairie you can find almost anywhere in the world. The more we destroy natural plant communities to convert the land for food crops, the more nutrient cycles are disrupted, and the more species go extinct. It is a most unnatural condition for any landscape. Perennials help solve that. Plant diversity is sort of nature's protection plan. The Land Institute has demonstrated that a mix of grains can be planted together and harvested together, and farmers can use existing farm tools. These practices can work anywhere and with a wide variety of crops. A major goal of the Land Institute is to get these methods up and running where they are needed the most. Wheat is the third largest crop in the world and the largest grown in Kansas. A transition from annual to perennial wheat has long been a priority on several continents. Shuwen Wang works on wheat DNA.
So we are trying to develop, a perennial wheat, for the, protection of soil, to reduce soil erosion.
Sorghum also offers enormous promise as a perennial. Stan Cox is a world expert.
This is a nursery where we're evaluating crosses between perennial sorghum and annual sorghum to develop new perennial varieties.
Sorghum is native to sub-Saharan Africa, so while continuing to work toward perennial sorghum populations that can thrive in the U.S. Central Plains, the Institute is also developing perennials for drought-stressed regions of tropical Africa and South Asia.
It's promising. So far what I've seen, when you look critical at this population, as time goes on, we have some plants that are able to come up after winter. Like last year, we had a very bad winter, but we noticed some families which were able to come back after.
Across the globe, one of the biggest costs for agriculture is nitrogen-based fertilizers. But with proper land use practices, nature can take care of the nitrogen.
We are capturing the nitrogen from the atmosphere. So that is our main basic motto to doing these experiments. So because in atmosphere is almost 72% of nitrogen present in the atmosphere. So that nitrogen we are capturing through the plants.
Good global teachers at the Institute don't just come in human form. Jackson urges farmers and planters to simply look at the Kansas prairie. What are the natural plants that are thriving there? Much of the prairie is robust and resilient without any costly artificial inputs.
A never plowed native prairie. It's been here for tens of thousands of years. The kind of vegetative structure that's been here during all interglacial periods of the Pleistocene, at least in Kansas. And no soil erosion, no fossil fuel dependency, no chemical contamination of the land and the water. Here's a system that is sustainable.
That's the same thing he'd like people to look at around the world as they figure out what plants to put in there. The Land Institute is also developing new crops, similar to some of those tough-as-nails native plants on the prairie.
So this is our intermediate wheatgrass, or as we call it, KERNZA breeding nursery. We have about 11,000 plants out here this year. We'll be harvesting each one of these. We brought it to the laboratory. Right now we're weighing each one separately, and within a couple weeks we'll decide which of these plants out here are the best.
KERNZA does not yet produce enough grain to be commercially viable, but big strides have already been made. Plants that won't gobble up water and fertilizers. What can we learn from the almost indestructible nuisance plants in the region? The weeds? The outcasts that seem to survive heat, cold, and drought? Well, the Land Institute is having success crossbreeding a plant known as silphium with other crops. For decades, Kansas farmers noticed this plant could live in any ditch or patch of ground. It may all sound new agey, but it's true. Everybody can win here. Farmers do better because they are not constantly buying new seeds and plants and fertilizer. Growing populations around the world have more food for their families. No matter the country, Jackson believes people can learn to live within their means. It's more than just saving the soil, it's saving our souls.